here we have a AP calculus AB problem. Okay, let's go to the information. Which of the following statements is true of f of x equals to negative x cube positive 18x square negative 105x positive 198. Okay, so in the given answer choices, I have information about the intervals where f of x is increasing or decreasing. So we have to find the one which is true in the given answer choices. Okay, since we have information about the intervals of increasing or decreasing about the function f of x, so what we have to do is we have to find the intervals where the given function f of x is increasing or decreasing. So for that, what I have to do is I have to find the first derivative of the given function f of x. So let me do it. So that is f prime of x equals to, so to get derivative of this negative x cube, what I have to do is I have to use a power law of derivative. That is, I have to bring this exponent in front of the variable and subtract 1 from the exponent. So let me take this negative sign as it is. So let me bring the exponent 3 in front of the variable and subtract 1 from the exponent. Then I'm getting 3x square. Okay, here the variable x square is multiplied by the constant 18. So whenever I find derivative, there is a constant multiplied by the variable, I have to keep the constant as it is and I have to get the derivative of variable alone. So to get the derivative of this x square, again I have to use a power law of derivative. That is, I have to bring this exponent 2 in front of the variable and subtract 1 from the exponent. If I subtract 1 from this exponent 2, I'll be getting 1. So usually when we have exponent 1, we don't mention, we can leave it, we can simply write it as x negative. So again, there is a constant 105 multiplied by the variable. So since we find derivative, I have to keep this constant as it is. So let's get the derivative of the variable x with respect to x. So the derivative of this x with respect to x is just 1 positive. The derivative of it's just a constant. This constant 198 is not multiplied by any variable. So whenever I find derivative of a constant, it will become 0. Okay, now let's do some simplification over here. F prime of x equals to negative 3x square positive 18 times 2x is 36x negative 105 times 1 is just 105. Okay, now we can factor the expression we have over here. So let me do it. F prime of x equals to, when I consider the coefficient of x square, the coefficient of x are constant term. So everything has the greatest common divisor 3. So we can factor 3 out. Since the leading coefficient is negative 3, we can factor negative 3 out. So when I factor negative 3 out, to get the stuff inside the parentheses, what I have to do is I have to divide each term of this expression by the one I factor, that is negative 3. So when I divide this negative 3x square by the one I factor, that is negative 3, the negative 3 and negative 3 will cancel. I'm just getting x square. So let me write it over here. Now, so I have to divide the second term, positive 36x has to be divided by negative 3. So 3 goes into 3 one time, 3 goes into 36, 12. So negative times positive become negative. So negative 12x we get. So that is when I divide this positive 36x by this negative 3, I'm getting negative 12x. Now let's divide the constant of negative 105 by negative 3. This negative will cancel. 3 goes into 3 one times and 3 goes into 105 35 times. Okay, now let me write the stuff over here. That is when I divide this one by negative 3, I'm getting positive 35. And also you can verify that by distributing negative 3 to this x square, negative 12x, positive 35. So whether we get the original stuff over here. So that the factoring what we have done is correct. So when you distribute this negative 3 to the x square, negative 3x square, negative 3 times negative 12x is positive 36x. Negative 3 times positive 35 is negative 105. Okay, prime of x equals to negative 3. Now let's consider the quadratic expression we have inside the parenthesis over here. So now what I have to do is I have to factor this quadratic expression. So whenever I want to factor quadratic expression in the form ax square positive bx positive c, so what I have to do is I have to multiply the constant term positive 35 over here by the coefficient of x square. So here the coefficient of x square is 1. So 1 times positive 35 is positive 35. So now I have to get two factors of positive 35 so that the sum of the two factors equals to the coefficient of x, that is negative 12 in this case. So I think negative 5 and negative 7 will work. When I multiply negative 5 and negative 7, I'm getting positive 35. When I add them, I'm getting negative 12, that is a coefficient of x. And also further we have to divide both these factors by the coefficient of x square, that is 1. Even if I divide negative 5 and negative 7 by 1, still I'm getting negative 5 and negative 7. So to get the first factor of this quadratic expression, I have to write x over here and then this factor negative 5. And then to get the second factor, again I have to write x and I have to write this factor negative 7. Okay, now just factored the expression over here completely. Now what we have to do is we have to equate this first derivative to 0 and solve for x. When I equate the first derivative to 0 and solve for x, the values I'm getting for x are called critical numbers. That means the values of x are the critical points. Okay, now let me equate the first derivative to 0 and solve for x. Negative 3 times x negative 5 times x negative 7 equals to 0. Okay, now, so here the product of three quantities equals to 0, -3, x95, x97. So definitely this one cannot be 0 because it's a constant. -3 can now be equal to 0. So, but the product over here has to be equal to 0. So if I want this product to be 0, definitely I'm pretty sure this one is not equal to 0. So either x95 has to be 0 or x97 has to be 0. Let me write the stuff over here. So x95 equals to 0 or x-7 equals to 0. So now if I solve this equation, I have to add 5 to both sides. In that case, I'm getting x equals to 5. So here solving this equation, I'm getting x equals to 7. So equating the first derivative to 0, I'm getting two values for x. So now what we have to do is we have to consider the domain of the given function. So here in the given function of x, we have a polynomial. So whenever we have polynomial, it's different for all real values of x. So the domain is all real values of x, and also once we get the value of x by equating the first derivative to 0, we have to make sure the values we get for x must be in the domain of the given function. Yes, 5 and 7 are in the domain of the given function because the domain of the given function is all real values because it's a polynomial. So we get 5 and 7. These two values of x are considered to be the critical numbers. And also one more check we have to do, that is we have to check whether there is any value of x for which f prime of x becomes undefined. So let's consider this particular step. So here the f prime of x equals to a polynomial. Since it is a polynomial, it is defined for all real values of x. There is no value of x for which f prime of x becomes undefined. In case there is a value of x for which f prime of x, that is first derivative, becomes undefined, that value of x also should be considered as critical number, and also it has to be in the domain of the given function. But we don't get any value of x for which f prime of x becomes undefined. So there are only two critical numbers for the given function, 5 and 7. Okay, now what I have to do is I have to draw a number line over here. Let me draw it. The left side extreme is negative infinity and the right side extreme is positive infinity. Now I have to mark these two numbers on the number line. So I'm getting 5 at first and 7 at next. Okay, now we have to split up this real number line into intervals using these two values, 5 and 7. The first interval I'm getting is negative infinity comma positive 5, and the second interval is 5 comma 7, and the third interval is 7 comma positive infinity. Okay, now what I have to do is so I have to check each of these intervals with the first derivative. So for example, I'm going to check the first interval, negative infinity comma 5. So let me take a random value in this first interval. So clearly we can take 0. So when I plug in x equals to 0 in the factor form of the first derivative, so what is the sign of f prime of x? The value doesn't matter. When I plug in x equals to 0, so this particular factor 0, negative 5 will become negative 5. And 0 and negative 7 will become negative 7. Let's multiply these two values, negative 3, negative 5, and negative 7. So negative times negative will become positive, positive times negative will become negative. So in this interval, that is when x belongs to, one second, let me write the stuff for negative infinity comma 5. The first derivative f prime of x is less than 0. So if f prime of x, the first derivative becomes negative, then the given function f of x is decreasing. Because the slope is negative, so the given function is decreasing. So in this way, we have to check each interval. Now let me take the second interval, that is 5 comma 7. So what is the value we have between 5 comma 7? Because each interval is an open interval. Always we have to write only open intervals on the number line. So like open intervals, we cannot consider the endpoints. We have to consider only the values we have between 5 and 7. So clearly we have 6 between 5 and 7. So when I plug in x equals to 6 in this factor, 6 negative 5 will become positive 1 and 6 negative 7 will become negative 1. So let's multiply these two values, negative 3, positive 1 and negative 1. So negative times positive is negative, negative times negative is positive. So when I take a random value in this interval, f prime of x becomes positive. Let me write the stuff over here. When x belongs to 5 comma 7, f prime of x becomes positive, that is greater than 0. Since the first derivative becomes greater than 0, that is, our slope is positive. So the given function is increasing in this interval 5 comma 7. Okay, now let me consider the third interval, 7 comma positive infinity. Let's take a random value. We can take 8 in this interval. So when I plug in x equals to 8 over here in this factor, 8 negative 5 is positive 3. When I plug in x equals to 8 over here, 8 negative 7 is positive 1. So negative times positive is negative, negative times positive is negative. So that is f prime of x becomes negative. When x belongs to the third interval, 7 comma positive infinity, f prime of x becomes negative, that is less than 0. Then again, since the first derivative becomes negative, so the given function f of x is decreasing. Okay, now I got the intervals of increasing and decreasing. Okay, now let's verify the options one by one. Let me go to the first option. So that is option A. Option A says f is decreasing on the interval 6 comma infinity. But we don't see this interval 6 comma infinity over here, since we don't have this interval. When I equate the first derivative to 0 and get the critical numbers using the critical numbers and splitting the real numbers into intervals, I don't get 6 comma infinity as an interval. Since we don't have this one as an interval, we cannot conclude whether f is decreasing over here or not. So we can reject option A. Okay, now let's go to option B. F is decreasing on the interval 5 comma 7. So clearly in the interval 5 comma 7, the given function f of x is increasing, but option B says decreasing in the interval 5 comma 7. So this is incorrect, so we can reject option B as well. Okay, now we can check option C. F is increasing on the interval negative infinity comma positive 5. So in negative infinity comma positive 5, clearly the given function is decreasing, but option C says f is increasing in the interval negative infinity comma 5, so we can reject option C as well. Okay, now we can check option D. F is increasing on the interval 5 comma 7. So 5 comma 7 over here in this interval, the given function is increasing. So the statement given in option D is correct. F is increasing on the interval 5 comma 7. Okay, now let's keep this one. Option E is none of this, so we can reject this one, because among the given answer choices, option D is correct. So the correct answer choice for this question is option D.